Hello everyone, I'm Simon Perez and my final project is about how to grow single copper sulfate crystals. In this picture are all the materials I used for my experiment. Some background information about this inorganic compound. Copper sulfate has the chemical formula CuSO4, and its most common form is its pentahydrate. This means that the molecules of the salt are combined with water in a 1:5 ratio as an integral part of its crystal. The pentahydrate CuSO4 has a very particular bright blue color, as you will see in the video. It dissolves exothermically in water, and when it is a solid, it shows an octahedral polymeric structure. Additionally, the aqueous solubility of copper sulfate is around 50 to 55 grams of sulfate per 100 milliliters of water at ambient temperature. Now let's move on to the experiment. To start the formation of the crystals, I first had to prepare a saturated solution of the salt. I started with 400 milliliters of distilled water in the Erlenmeyer flask. Theoretically, I could dissolve around 200 grams of the salt in this volume of water, but since I did not have a balance, I had to find the saturation point experimentally. To do so, I added the sulfate little by little to the water until the solution could not dissolve any more salt. Here you see this paper funnel that I made because I noticed it was going to be easier to transfer the solid to the flask this way. At the end, I used a heating plate to help me dissolve some solid remainders that were sitting on the bottom of the flask. However, it is very important to avoid saturation because that will favor polycrystallization, and we're trying to get single crystals. Here you can see the final saturated solution that I used for the experiment. Once I got the saturated solution, I transfer a small volume of less than 50 milliliters to a beaker for it to sit overnight. Also, to avoid the solution to interact with the environment as much as possible, I put it inside a styrofoam cooler until the next morning. The following day, I removed the beaker with the solution from the cooler, and as it is shown, there was some precipitation. Some very small crystals were formed at the bottom of the beaker, and those are known as seeds. I chose some of my favorite and I extracted them using tweezers. I chose a couple of them and I tied them using some thread so that they could hang from a pencil to the solution. I heated up the solution that I made the day before to dissolve all the mini crystals formed at the bottom of the flask, and then I transferred the solution into two different beakers. When the solutions were back at room temperature, I suspended each crystal in a beaker and then put them back in the cooler for them to start growing slowly. After 4 days of growing, this is how the crystals looked. They were looking great, very symmetric, and without any big polycrystallization. The polycrystals observed are there because the thread absorbed and stored some solution, making some crystals grow on it too. The growth happens because of intermolecular attraction. The particles of the salt in solution attach to the seeds and make the crystal grow until equilibrium is reached, which is why after a few days I have to change the solution so that the growth continues. I filtered both solutions using the funnel and filter paper to remove the impurities that could be in solution and cause deformation in the crystals. As you can see, there were a lot of ugly-looking impurities that probably came from the water. After filtration, I had to saturate the solution again following the initial procedure. Before transferring the solution back into the beakers, I filtered it one more time just to make sure the solution was as clean as possible. I replaced the threads, carefully removed the tiny crystals that were around the bigger ones, and when the solutions were clean and cool, I put the crystals back in for them to keep growing. They grew for a total of 10 days, and these are the final results. In a little more than a week, the crystals are at least 10 times bigger than the original seeds. If I keep repeating this procedure, they can keep growing and growing. This was a very interesting, easy, and fun experiment to do at home. Everything I used to do it can be found on Amazon at very reasonable prices. I hope you enjoyed my video. Thank you very much.